All right, everyone. So in this video, we're going to review the atomic theory prompt. So remember, when we look at atomic theory or any gateway prompt, the title is going to be the theme to your essay. And as we go through this, we're going to underline our key vocabulary. We're going to define the words as we go. They can add a lot of background information to our essay. And we're going to look at making the connections that we see between the documents and what they're asking us to do. So we'll begin with our scientific background. Remember, this is what you summarize to go in your introduction, and I'll have a different video where we go over how to write an introduction and a conclusion paragraph at a later time. So during the 20th century, scientists studied the structure of the atom and changes that atoms undergo during nuclear reactions. As part of a team working on identifying isotopes and explaining their formation, a task is given to analyze data about silicon. Scientists want to determine the identity of an unknown isotope and validate claims about the production of silicon during nuclear fusion. So we have a few vocabulary words here, or just important words, and we'll go through and define which ones we can. So we know an atom is the smallest unit of matter, and they make up everything. So all of matter, everything we see and everything we don't see, is made up of atoms. And a nuclear reaction is a reaction involving the nucleus of the atom. That's why it's called the nuclear reaction. And an isotope. So this is going to be really important. So an isotope are atoms of the same element, and if they're the same element, that means they have the same number of protons with different mass numbers. And the reason why they have that is because they have a different number of neutrons. So we can use that. Now, we know that silicon on our periodic table is Si, and I assume that they're going to give us a periodic table. It appears they don't, but they do give us the symbol here, and they give us some other information in the documents that we'll look at momentarily. But silicon is Si, and it says scientists want to determine the unknown isotope. Nuclear fusion, so remember, fusion means to combine. So nuclear fusion is when the atom's nucleus combine into a new atom. Okay, so this is how new atoms and elements are created. Typically happens in the stars. Okay, although it can happen in machines, there are man-made ones that we look at and use. So let's look at the writing task. So it says to construct an explanation. So the word construct is our directional term. It's what it's telling us to do. So using the data provided on how isotopes are formed and how their subatomic particles might vary. So these are the two things we need to make sure that we hit upon. So we've got task number 1 and task number 2. And to answer those two things and complete those tasks, they're going to give us 3 bullet points. Now remember, the first bullet point is body paragraph number 1. And so this means we will be able to organize our essay this way. The second bullet point should be body paragraph number 2, and the third bullet point should be body paragraph number 3. The first one says to use the 3 isotopes of hydrogen to explain the characteristics of isotopes. Okay, so they want to know what makes something an isotope. In your discussion, be sure to include all 3 subatomic particles. So remember, the 3 subatomic particles are protons, neutrons, and electrons. Okay, so we'll talk about those with the isotopes of hydrogen. And the our directional term is to explain and include and justify. So using document B, calculate, so that's our directional term, the number of protons and neutrons that the unknown isotope contains, explain which isotope is more commonly found in nature, and justify your reasoning. And then in the third one, we need to explain nuclear fusion and show how isotopes of silicon might be formed if you start with a carbon atom. So let's look at our documents. So we know that in bullet point 1, we're looking at the 3 isotopes of hydrogen, which are given to us in document A. So that means we would cite this in body paragraph number 1. One thing to keep in mind is here, this notation is called symbolic notation, okay, because it includes the symbol. And so this number in the top left corner is the mass number, and this right here is our atomic number, which is the same as the number of protons. So we can see that because I have 1 proton and this is 1 electron, okay, that means since there's no number here, there's 0, so this is a neutral charge. So this is what we can look at. Whereas this second one, the mass number is different, and that's because we have 1 proton and 1 neutron. Okay, so our mass is equal, oops, sorry, the handle off on that, but the mass number is equal to my protons plus my neutrons. Okay, and here I have a mass number of 3, and that's because I have 1 proton and I have 2 neutrons. But in both of them, I still only have 1 electron, and they all maintain a charge of 0 or neutral. So when we look at the characteristics of isotopes, we can talk about how they have what they have in common and what they have different. So we can say that they have the same number of protons, right? Because we see that the protons are the same, which is why they're all hydrogen, because they all have 1 proton. They all have 1 electron, which is why they all have a neutral charge. And then they have a different number of neutrons. There are 0 neutrons in this first one, and that is what changes their mass numbers here. That's what's different. So that's what we'll kind of discuss in our first bullet point. If we look at document B, the percent abundance of silicon. Now, percent abundance is one of our vocabulary words. It basically tells us in percentage form how common an isotope is. And so we can see that silicon-28 makes up 92% of the silicon in the world. Silicon-30 takes up 30%, and 5% is made up of this mystery element here. Now, percent abundance is helpful because it allows us to calculate the average atomic mass. The average atomic mass can be found on your periodic table, which you will be given a copy of the periodic table on the gateway exam. And if you look at silicon on the periodic table, silicon is number 14, and it has an average atomic mass of 28.09. The number 14 tells us that there are 14 protons in silicon, so that helps us answer part of it. We know that for all 3 of these to be silicon, then they all have 14 protons. The question is, how many neutrons does our mystery silicon isotope have? Now, the way that the average atomic mass is calculated, which on the periodic table, the average atomic mass is the number at the bottom. It's a mass of average of all of the isotopes based on their percent abundance. The way you calculate it is it's your mass number times the percentage plus the mass number of the next one times its percentage, and you keep going for however many isotopes there are, all divided by 100 since it's a percent. So what we can do is we can use this to calculate our missing mass number. So we know that the average atomic mass of silicon is 28.09 and that it's equal to our numerator over 100. So the mass of isotope number 1 is 28 and its percentage is 92%, and it gets added to the mass of isotope number 1, which is our X, it's our mystery, times 5%, plus the mass of isotope 30 times the 3% that it is, all over 100. So what we do to solve for X, okay, is anytime we have to move something to the other side of the equation, we do the opposite of the math. So that means we're going to multiply by 100 on both sides to get rid of the 100 in the denominator. So 28.09 times 100 will give us 2,809, and it's still equal to our initial numerator, plus 30 times 3. Okay, what we can do is we can simplify on the right side by going ahead and doing the multiplication. So 28 times 92 is 2,576, plus, we can't really multiply anything there, plus 30 times 3 is 90. We can simplify further by just going ahead and adding those two numbers together. So 2,576 plus 90 is 2,666 plus our missing amount. To move this number to the other side, we'll have to do the opposite of the math, which means subtracting that amount on both sides. And 2,809 minus 2,666 is 143, and it's equal to X times 5. So what we do to get X by itself is we do the opposite of the math. We will divide by 5, and that tells us that X will be equal to 143 divided by 5 is 28.6. So since our isotope amount needs to be a whole number, this rounded to a whole number is 29. Therefore, we can assume that this missing is 29, and therefore we know that the mass is our protons plus our neutrons. So if I have a mass of 29 and there are 14 protons, that means to figure out our neutrons, we subtract 14 on both sides, and I'm given that my number of neutrons is equal to 15. So that means our missing isotope will have 14 protons and 15 neutrons, according to our calculations. We also could have estimated this by knowing that the average atomic mass is 28.09. Therefore, these other ones, since they're so small, because the average leans higher than 28, that these are both probably bigger than 28. And our mystery one was kind of probably in the middle. But to be sure, our calculation is always there for us. So if we look at document C, okay, it shows how you can create you can use two isotopes to create an isotope of silicon. So what happens is, this is an example, nuclear fusion. And so you would have your isotope 1 and isotope 2. They would combine to have a mass number of 28 and an atomic number of 14. So this would be silicon here. And then for nuclear fusion, it's just showing that two atoms, so this is atom number 1 and atom number 2, they collide with a lot of energy and they create a new atom. They fuse together. Okay, so this is an example of that. Now, bullet, we are definitely number 2, because it wanted us to calculate. It also wanted to explain which one was the most common, and we can see that as being isotope 28. It's 92%. But document C and D are for body paragraph number 3. Okay, so both of these would be used in body paragraph number 3. It does want us to show how we could form a isotope of silicon if we started with a carbon atom. And so what we can do is, if we look at the carbon is number 6 on the periodic table, and most carbons have a mass of 12. And if you combine 2 carbons together, okay, you will get 24 and 12, and number 12 on the periodic table is magnesium. Now, the goal is we would need to get all the way to silicon, and we notice that we're 4 and 2 away from what we need. So helium has a mass of 4 and an atomic number of 2, and if we add a helium atom into that, that will also give us the mass or the isotope of silicon that we need. So if we're starting with carbon, we'll need 2 carbons and 1 atom of helium, and we can create silicon. And so this will help us with that. That's what we'll talk about in bullet number 3. So this is kind of how we figure out that information, and hopefully you are refreshed in your understanding of isotopes, average atomic mass, and nuclear fusion and how it happens.